John Griffiths is an electrical engineer and founder of Context CA with over 35 years of electrical engineering experience, including 20 in healthcare. He played a central role in the design and engineering of groundbreaking healthcare microgrids, including Faraday projects at Kaiser Richmond, the San Benito Clinic, and Kaiser, Ontario. As a member of the Hospital Building Safety Board of HCI and one of the lead authors of the recent healthcare microgrid white paper, John is an expert on microgrid designs, such as now are being required for skilled nursing facilities.
Healthcare electrical design. Jamie's outlined, quite a few challenges that this new requirement is going to bring to a building type that we didn't normally need to meet. So, what are the challenges? Most of the existing SNFs that need to meet this requirement are going to be existing, and they're going to be a different age of building environment. So as an electrical engineer, there's a number of on this call, you really need to consider when we're applying these power systems, what do we do? There's a number of approaches to do that, but I think that's the first step is a healthcare engineering experience in delivering those is really understand what you have. And then, limited capacity and distribution. When we started thinking about, Faraday and Contact and HCI, how do we deliver these? We got distribution points that we need to meet. So to make a system actually work, we need the power source, we need the fuel source, but we need all those little bits and pieces, such as the HVAC controls, to make it ultimately work to serve these young ladies in the picture. And then the other challenge is, and an opportunity is, as we look at delivering sustainable microgrids, there is an unfamiliarity with these solutions. We and Contact and the other engineers on here, we're very familiar with delivering diesel generators, but as we approach and deliver these more sustainable solutions to meet not only provide better solutions, but also meet the state's goals and address climate change challenges, we need to educate everyone and be prepared to take some risk, but do it comfortably with employing experts. So what are the opportunities? Ongoing savings, the other presenter is going to talk about that value of sustainable microgrids. But the other thing is, an electrical engineer, I always like to share with my clients is that system is always on. It's synchronized with the utility. And one of the challenges with other distributed generation systems that only come on, if there is a problem, you only know about that when the power goes off, and that's not when you need to know about it. And then seamless transition. Again, a small point, but when you're evaluating, and the owners here on the phone, on the call, is, okay, diesel generator or other distributed source is 10 seconds plus up to a couple of minutes for the other systems to come back on. Again, meets code. The intent is to keep the temperatures and keep the building safe. But in terms of operating a facility, that can be quite disruptive. Resetting technology, resetting air handling units, fire smoke dampers and doors. And I think is a value of delivering a sustainable microgrid. So you're probably saying that's all fine, right? There's different solutions, but have you done it? And healthcare is particularly challenging. Well, this team has, working with Contact and working with Faraday microgrids, we've delivered a number. So I'm just going to quickly run through those. So this one I think is relevant to the SNFs. This is the San Benito Community Clinic in Hollister, California. And so, this picture on the left, you can see that originally it is a community clinic. It's not high occupancy. So, our approach here was go to the site, evaluate it, look at our loads. There was a relatively new generator. We incorporated that into a hybrid inverter. So we're able to use a generator when we need it. If there's not enough battery, and we have batteries and solar. So this improved the resilience. But the other important point is when you're approaching that, if you're a facility to meet these requirements, is look at reducing the loads. We did LED retrofits, HVAC upgrades, and that's an important step that shouldn't be overlooked, because as an engineer, we're happy to design you a big system, but I don't think that's what you want to pay for and also operate, but reduce the loads. So this is providing us, this particular project, I feel particularly proud to be part of it, is to providing sustainable, resilient power to what is a traditionally underserved community. So another example, this is the Kaiser Richmond microgrid. David touched on that first, HCI sustainable microgrid in California. probably in the US, installed and commissioned without interruption. It's an HKI project. And right now, ever since it was installed and operated in 2018, this has been supporting the existing infrastructure. You can see the solar panels on the roof of the parking structure, and that's providing ongoing energy savings. So it is, skilled nursing facilities are not high occupancy. It is possible to connect, operate, and run sustainable microgrids on healthcare facilities. So, this is a current one, and most of the people on this call are involved in. Super excited to be part of the team. Kaiser Ontario Microgrid. It's the largest HKI sustainable microgrid in California, and again, probably in the States. It will be able to support the entire facility. So I know David and the rest will talk about this more, but amazing project, and kudos to the CEC for being behind this project. And then probably more relevant, this is another project that Contech and Faraday are working on, is the Tamalpais Pediatric Practice in Novato. B occupancy, but we are utilizing a sustainable microgrid. And one of the key points that does come up when you are evaluating, speaking to your electrical engineer, your developer, is what about the sustainable criteria for the components? And on this one, we're using a second life battery. We're working with a company called Repurpose Energy, and they're essentially valuable Nissan Leaf batteries, and that's going to be the entire facility. It's not 24-hour operation, but when there are major issues, they are at full capacity right now. They are able to support that and will be 24 hours plus. So that's a quick blast of the sustainable microgrids that we've delivered, and hopefully we can deliver on these to support the new requirements. Thank you.